Hello and welcome to a video on rationalising the denominator of a fraction. In this video we're going to talk about what we mean by rationalising the denominator, why we do it, and also we're going to get some practice at going through some examples on the process and the techniques used to rationalise a denominator. So first of all, if we have a look at this fraction over here, we've got two types of number in this fraction. We've got a rational number, 4, and we've also got an irrational number, which is the square root of 2. So first of all, what's the difference between a rational number and an irrational number? Well, if we think about 4, we can write 4 as 4 over 1. We can write that as a fraction. 4 divided by 1 is 4. Okay? Or we could write that as 8 over 2. That is also 4. Okay? Or we could say that 4 is the same as 4,000 divided by 1,000. This is also 4. So all of these different terms that I've put up here, these are all equivalent. Okay, they're all equal to 4. So a rational number is a number that can be written as a fraction, where the top number and the bottom number are both integers. So an irrational number, you can probably guess what an irrational number is. So if we use the square root of 2 as an example, an irrational number is a number that cannot be written as a fraction. So if we wanted to write the square root of 2 as a over b, where a and b are both whole numbers, well, this cannot be done. Okay, there are no two numbers that when we put into this fraction will give us the square root of 2. Okay, and that's the difference between a rational number and an irrational number. Okay, so when we're talking about rationalising the denominator, all we're talking about is basically turning this, an irrational number, into a rational number. Okay, so just getting rid of this square root symbol. That's what we mean by rationalising the denominator. And why do we do it? Well, there's a few different reasons. The main reason is because a lot of the time we can actually simplify this. We can make this fraction a lot simpler so that when we perform further calculations, it's a lot easier to deal with. Okay, so without further ado, let's go ahead and rationalise this denominator. So let's go through the steps involved. So first of all, I'm just going to write this out again. So we've got 4 over root 2. Okay, now to rationalise a denominator, all I do is I multiply the top and the bottom by that number. Okay, I just multiply the top by root 2 and the bottom by root 2. Notice how I'm not changing the value of my original expression, because this here, anything divided by itself is 1. So this fraction is just 1. And whenever I multiply anything by 1, that just gives me the original number. So I'm not changing the value of the expression. The reason why I've done that is so if we look at the bottom here, the root 2 times root 2, well, that is just 2. Whenever we have a square root of something and then we square it, that just undoes the square root operation, so we're just left with 2. And then in the numerator, 4 times root 2 is just 4 root 2. Now we can simplify that even further. Notice how the top and the bottom are both divisible by 2. So 4 root 2 divided by 2 is 2 root 2. And 2 divided by 2 is just 1. So we can just write that as 2 root 2 over 1, or just 2 root 2. And that is our answer. And notice how we went from a fraction into something where we've lost the fraction. So it's a lot easier to deal with now. It's a lot more simplified. This won't always be the case, but that's one reason why we rationalise the denominator. So we just multiply the top and the bottom by the denominator. So let's go through a few more examples. Okay, so we want to rationalise the denominator. So again, we just multiply the top and the bottom by the denominator. Okay, so this number here, we just multiply the top and the bottom by this number because we're not changing the value. Okay, so on the top, root 2 times root 3, well, that is just root 6. And in the denominator, root 3 times root 3 is just 3. So we've rationalised the denominator. We've gotten rid of that square root symbol. Now, if you're unsure how I got root 6 here, so root 2 times root 3, well, that is the same as root 2 times 3. Okay, 2 times 3 is 6, so that is the same as root 6. Okay, let's go down to another one. So 5 over root 2, so again multiply the top and the bottom by root 2. 5 times root 2 is just 5 root 2. And root 2 times root 2 is just 2. And that is our answer. Okay, we can't simplify that anymore because there's no common factors. So that is our answer. Okay, let's go down a bit further. So here, 1 over root 10, again, we're going to multiply the top and the bottom by root 10. On the top, 1 times root 10 is just root 10. And on the bottom, root 10 times root 10 is just 10. And that is our answer. So notice how for each one, I'm doing exactly the same thing. I'm just multiplying the top and the bottom by this number here. Okay. So this one here, so 9 over root 6, again, just multiply by root 6 over root 6. In the numerator, 9 times root 6 is just 9 root 6. Root 6 times root 6 is just 6. Now you might be tempted to leave that as your answer. However, I can see that we've got a common factor of 3. 3 goes into this number. 3 also goes into this number here. So if we divide top and bottom by 3, we get 3 root 6. And then 6 divided by 3 is 2. And that is our fully simplified answer. Okay, got quite a few more of these to go through. And hopefully you're pausing the video each time and giving it a go yourself. Now this one's slightly trickier, but it's exactly the same process. So I want to get rid of that root 5 on the bottom. So I just multiply the top and the bottom by root 5. Okay, I want to get rid of this, so I just multiply the top and bottom by that number. Okay, so 3 times root 5, well that is just 3 root 5. 2 times root 5 times root 5, well root 5 times root 5 is 5, so 2 times 5 is 10. Okay, so this here, so this times this gives us 5, and then 5 times 2 gives us 10. Okay, scroll down. Okay, so we want to get rid of that root 20, so multiply the top and bottom by root 20. Okay, so 5 times root 5 times root 20, well that is the same as 5 times root 20 times root 5 is root 100. And then root 20 times root 20, that is just 20. Now we can simplify this even more, so hopefully you know what the square root of 100 is. So that is the same as 5 times the square root of 100 is 10. And then divide that by 20. 5 times 10 is 50, so that's the same as 50 over 20. And then we can divide top and bottom by 10. That is the same as 5 over 2. And that is our fully simplified answer. So actually with this particular scenario, we've gone from something that's quite complicated and will be quite hard to deal with if we had to use this as an input to one of our questions, if we had to sort of use this to answer a question, but we've gone from that to something that looks like that, which is a lot simpler. We could also say that that is just 2.5. Okay, it's a lot easier to deal with. So another key reason why we rationalise the denominator. Okay, I think I've got one more to go through. So again, we want to get rid of that root 5, so we're just going to times the top and the bottom by root 5. Okay, so on the top, we've got root 5 multiplied by root 2 plus 1. Okay, we're multiplying this whole thing by root 5. And on the bottom, root 5 times root 5, well, that is just 5. Okay, so now we can expand the brackets. Okay, root 5 times root 2, well, that is root 10. And then root 5 times 1, well, that is just root 5. And then on the top, we've got, on the bottom, sorry, we've got 5. And I don't think we can simplify this any further. No, these are as simplified roots as we can get. We can't factor out anything from both of those. So that there is our final answer. So hopefully you got a lot out of that video. In a future video, I'm going to look at slightly more complicated questions that involve rationalising denominators, where there's actually an expression in the denominator that has more than one term. Okay, so thank you for watching, and I hope you enjoyed that.